We're going to talk in this video about how we make alkynes. So we can start to make alkynes from a couple of substrates. Let's say that I have a molecule. This is a dialkyl halide. In this type of dialkyl halide, notice that we have two halides on the same carbon. So this is called a geminal dialkyl halide. And the other way that I can do that is putting this to using a compound that will have two halides but next to each other. So this is a vicinal. So carbon 1 and 2. We can use either one to make alkynes. What we used to do, the reaction that we would use is an elimination reactions. And what we do here, again, we will have a base. It is also required that we have to have, say this is your alpha carbon, but next to that, we need to have a hydrogen. So we need to have beta hydrogens for that elimination to happen. So typically, we use an excess of sodium amide on the first step. And then we need water or acid here. Same condition here. So that's a very strong base. We have learned that this basic conjugate acid is ammonia. pKa of that is 38. pKa of ammonium. So very strong base. And here we're going to be using the same to make, so an excess, we write it like that. So that's my counter ion, right? So that's sodium amide, and the second step, water. So what we are going to do here is an elimination reaction. And again, for that to happen, if we're doing a beta elimination, and again, two consecutive beta eliminations, we need to have beta hydrogens. So notice that here I have beta hydrogens. So let's do one of these reactions. I'm going to redraw that over here. Say that I have a bromine, another bromine, an H, and I here have 3 beta hydrogens. Same here, it's the same thing. But I'm going to draw just only one of those. What's going to happen then is that your base, here's a plus, this negative, your base is going to get a product in the beta 2 elimination. You're going to do that. That will create an alkene in the first step. And then notice that here we're using an excess. So in your first step, you're making that double bond. So you still have another bromine, right? So you're going to do another elimination. And here at this carbon, you still, remember that was a CH3, I drew 1, but still have 2 H's. So in another, that is, here you're going to need to, you're going to do another elimination step, and you're going to make the triple bond. Here you have adjacent in a carbon that is adjacent to where the alkyl is, you have a beta hydrogen. So now you will be making your alkyne, but so eliminating this two, making the triple bond. But since you are in the presence of a strong base, you're really not getting that. You immediately will be having the alkyne ion. So to recover that, you must add water to actually have the alkyne. So that will be the process in which you do this reaction. So again, you need 2 halides, either geminal or vicinal, so next to each other, and you have to have hydrogen. So here you need to have 2 hydrogens. You have removed one in the first step. So you remove in the first step this and that. You form an alkene, and then in a second elimination step, again, beta hydrogen, and you remove the second halide, you form an alkyne. because you are in the presence of such a strong base that is in excess, you will form the alkyne anion, and you need the second step here, water to protonate. And so very similar what happens in that case here with the vicinal. But let's say I'm just illustrating one of those. Here, remember that I have metal bromine, and I do have an H here. So in the presence of that strong base, and let's say I have a plus, that is not a very strong. So what I'm going to have is now another E2 reaction. Let's grab this proton, you make this double bond, and you form an alkene. And notice that this is the same alkene, right? So you can start from either, again, the geminal or the vicinal. Once you have the alkene here, you will have that same thing that you had before, and you will have another elimination step. You have attach that and remove. So in summary, we need an excess to sodium amide to remove in the first step one H that is next to where the halide is, right? We make a double bond, a second elimination to make the alkyne, and again, require that you have the other H there next to where the bromine is. So you make the alkyne, and the second step is necessary to protonate the alkyne anion. Notice that this is also here. Here you have an excess. In the first step, you did the first elimination. You form the same alkene here, and then we go back to that. So either geminal or vicinal alkene will work in making alkynes.